Okay, so we got back from our big adventure. We've got a whole bunch of data, and we really want to get it into our BigQuery table quickly before it goes away. Fortunately, we have a bit of time to do something about it because anything that's in a Google PubSub subscription will last for 7 days until it expires. So we've got some time to do something about it. Still, I'd love to get my stuff out of PubSub and into BigQuery as quickly as possible. So the quickest way to go about this is we're going to set up a virtual env in our Cloud Shell. And the reason we do this is because we're not running as root, and changes to the system don't persist across instances of Cloud Shell, whereas changes to your home directory do. So this is a good way of keeping any of the changes that we make in terms of packages that we download that we need to run our script. We have to activate that virtual environment. Next thing we're going to do, let's clone our Git repository so we get all of our Taxi Datalogger project. Now, of course, we don't actually need all the source. We're really only interested in the stuff that's in the scripts directory. So we'll just go there. Perfect. Okay. So we've got a bunch of scripts. What we've got to do now is we've got to actually edit the setup.yaml file to, we just need to change this for our project. We really only need to change it in 2 places. And if you're lucky and you're using the Cloud Shell, your project name should actually be written right there in your tab. So let's just put Taxi Datalogger there. Now obviously your project is going to be different, so don't type exactly what I'm typing. Okay. Now I don't normally use Nano, but don't want to start any kind of arguments about what editor to use, so I'm using Nano. All right, perfect. Okay, so I've changed setup.yaml, and now the only thing I have to do is run this pull script. Okay, no, I have to do one more thing. I forgot. I need to install all the dependencies, which is why we set up the virtual one. There we go. Just pip install the requirements file, give it a little bit. So I'm going to run, the next thing I'm going to do is run the script, which is going to pull my data from my subscription that's named the storage subscription and copy it into the big table, BigQuery, excuse me. There's one thing that we don't have to do when we're using Cloud Shell, which is really convenient, is we don't have to use our service account credentials. Now, we created those early on in the credentials step of this project, and I said you'd need those for running scripts. The exception is with Google Cloud Shell, and because it's Google Cloud Shell and it's running in the rest of your Google services, it actually already has the credentials that are needed to access the resources of your project. So that's actually pretty awesome because it lets us save some time, and I'm all about saving time. So yeah, the next thing we do is we just want to run the script. So pull taxi pub sub should just do it. And there we go. And this is going to run for a bit. Okay, fantastic. So it looks like it's done. Now we just have to press Control-C to exit from this, and we're done. Okay, so now that we've got our data in Google BigQuery, we can query the table and do some pre-processing on it. So there's several ways to pre-process the data, but the simplest way is to just perform another query on it that aggregates the data and then save that result as another table. So I've got a query that will do exactly that. So one thing that's really fortunate about longitude and latitude is if you change the number of, if you round off the number of digits, you can actually get really nice values for the range of distance they represent. So as it turns out, 3 decimal places of precision will give you basically a resolution of 110 meters. So basically what I'm saying here in this query is I'm saying round off the digits so that we get basically a box that's 110 meters by 110 meters and average all the points that fall inside of that so that we only get one value for every 110 meter box. as a result, we sort of get a grid, and we can actually get some useful values that we can map. Otherwise, if we try and map all the values, what we get when we show a heat map is really, it's just going to show us a heat map that represents how many values we have in a particular place, which is kind of how much time we spend in a particular place. Perfect. So we can run this query, and we get 586 results. And all we really want to do right now is we actually just want to save that result. And we want to save that result to a table that we're going to call aggregated sensor values. And we're also going to want to save it to Google Sheets. And that's it. Now we're going to go produce our heat map. So now there's basically two ways that we can go about making a heat map. So the first one I'm going to show you is to use Google Fusion Tables, which is a bit of an older product, but what it lacks in power, it makes up for in simplicity. So if you go to Fusion Tables, I don't know why it redirects you to the support answer, but fusiontables.google.com. Anyways, there's a button there. You click on Create Fusion Tables, and you just very quickly click on that spreadsheet that you saved from BigQuery. And it loads it. Column names are in row 1. That looks fine. Just hit next. If you allow export, other people can use your data set. I choose not to. Click finish. And literally you're almost done. All right, so we've got the rows in there, and you've got a map. If you move over to this map tab, like really quickly here, we just see all our data points. Now, the data points are obviously in these 110 meter boxes that we mentioned. If we zoom in, you kind of see the grid-like nature of these points, right? This is that's exactly what we did. We said every 110 meters, let's average all the sensor values we have and make it into a single point. So that's exactly what we've done. Okay, so the next thing we can do is, these are still points. So on the left, you see there's feature map and there's heat map. All you have to do to turn into a heat map is click heat map, and we've got a heat map. This is an uninteresting heat map because there's no weighting, so it's really only giving equal weighting for every point, so it looks pretty homogeneous. We can change that. We can just click on the weighting here and hit PM 2.5, and now we've got a weighting. So you can play with the opacity here, but what's more interesting is play with the radius, and then you can sort of see, maybe these areas that are a little more red are a little more polluted. Maybe not, because we don't have a lot of data, but this is definitely a pretty cool tool to investigate this with. And that's it. Okay, on to the next way to represent a heat map. And finally, we can display a heat map in a normal regular web page using the Google Maps JavaScript API. So your Cloud Shell should be set up from when you synced your data from PubSub to BigQuery. And we can just go into our Taxi Datalogger scripts directory here. You should have a heat map HTML file. So we can just edit this using whatever editor you prefer. And you just need to update your Maps API key, your OAuth client ID, your project ID, and you can also change the center longitude, latitude, and zoom level if you'd like, because at the moment it's set to focus in on the middle of Lima. Okay, so just exit out of here. I've actually got one that's pre-edited with the right credentials because that would take too long to show you right now. So we can just go straight to running a simple web server that'll serve up this web page. So Python's got a built-in module that knows how to serve HTML pages, and we can just click this web preview button in the Cloud Shell, and it basically open up the tab. Okay, so we've got it open. There's one more thing we have to do. This host has not been whitelisted in our OAuth credentials, so we need to go and open up our OAuth credentials, which I can just jump to right away. And you need to add it here. You need to add the host name, the URI, under authorized JavaScript origins. You just click it there. Notice how I left out all the path parts that are normally part of the URL, and I'm just leaving the HTTPS and the host name. And just click save. And then we can jump back here, and this should work. So we just click heat map edited. And you need to use the rectangle selections tool here to select the area that we want to query, and we'll just do that. And voila, there's our heat map.